Today we are going to talk about the application of MIMO technology in LET system. The LE and the LTE system. The LTE, as defined by the third generation partnership project, is a highly flexible radio interface. It provides a significant increase in spectrum efficiency compared to previous cellular systems and a new flat radio network architecture designed to simplify operation and to reduce cost. LTE also aims for a smooth evolution from earlier 3GPP systems such as time division, synchronized code division, multiple access, which we also call TDS-CDMA, and wideband code division, the high-speed packet access, as well as 3GPP2 systems such as the CDMA 2000. And LET also constitute a major step towards international mobile technology advance. Multiple antenna techniques which can be used to increase data rate through multiplexing or to improve performance through diversity is adopted as a key component of LTE. So here we are going to talk about the three major problems. So the first one is the utilization of multi-antenna technology in LTE system, and then the principle of multi-antenna technology is discussed in detail, and then a brief introduction to LTE system is presented. Finally, the application of multi-antenna technology in LTE system is provided with several practical constraints taken into consideration. So the MIMO system can be seen as a system which uses multi-antenna as the transmitter and receiver. A MIMO system takes advantage of spatial diversity that is obtained by spatially separated antennas in a dense multipath scattering environment. MIMO system may be implemented in a number of different ways to obtain either a diversity gain, to combat signal fading, or to obtain a capacity gain. Generally, there are three categories of MIMO technology. The first aims to improve the power efficiency by maximizing spatial diversity. Such technology includes delay diversity, STBC, and STTC. The second class uses a layered approach to increase capacity. One popular example is V-Blast, where full spatial diversity is usually not achieved. Finally, the third type employs knowledge of channel as a transmitter. It decomposes the channel coefficient matrix used SVD and uses this decomposed unitary matrix as pre and post filters as the transmitter and the receiver to achieve near capacity. And then we'll talk about the spatial diversity. For full diversity, each transmitter symbol must be assigned to each of the transmit antennas at least once in the course of the symbol duration. The resulting symbol to transmit signal mapping function is called space-time block codes. Although many designs of STBC exist, additional properties such as orthogonality of Y allow improved performance and easy decoding at the receiver. Such properties are realized by the so-called Almaty spacetime code. And a simple method to achieve space multiplexing is at Bell Lab, which is called B-Blast. It is a parallel encoding as illustrated on the right. And then we'll talk about the MIMO channel decomposition. The optimal way of communicate over the MIMO channel involves a channel-dependent precoder, which fulfills the roles of both transmit beamforming and power allocation across the transmit streams, and the matching receive beamforming structure. Full channel knowledge is therefore required at the transmitter side, and for this method to be applicable. Then we will talk about the LTE system. Mobile broadband is becoming a is becoming a reality as the internet generation grows accustomed to having broadband access wherever they go, and not just at home or in the office. Out of the estimated 1.8 billion people who have who will have broadband by 2012, some two-thirds will be mobile broadband customers, and the majority of these will be served by HSPA and LET system. People can already browse the internet or send emails using HSPA. Uh, and with LET, the user experience will be even better. It will be further enhance more demanding applications like interactive TV, mobile video blogging, advanced games, and professional servers. The LTE offers several important benefits for customers and operators. The first one is performance and capacity. One of the requirements on LTE is to provide downlink peak rates of at least 100 megabits per second. The technology allows for speed over 200 megabits per second. Therefore, furthermore, the radio access network round-trip times shall be less than 10 milliseconds. In effect, this means that LETC, more than any other technology, already meets the key 4G requirement. The second benefit is simplicity. Simplicity. So first, LET supports flexible carrier bandwidth. Then LET, the second because LET radio network products will have a number of features that simplify the building and management of next generation network. Third aspect is LET will be developed in parallel, which with simplified IP-based core and transport networks that are easier to build, maintain, and introduce service on. The third benefit is wide range of terminals. In addition to mobile phones, many computer and customer electronic devices such as notebooks, gaming devices, and cameras will incorporate LTE embedded modules. Since LET supports handover and roaming to existing mobile network, all these devices can have a lot of mobile broadband coverage. The fulfillment of the extensive range of requirement is only possible thanks to the advance of underlying mobile radio technology. There are three fundamental technologies that have shaped the LTE radio interface design: multi-carrier technology, multi-antenna technology, and the application of packet switching to radio interface. And now we will focus on one of them, which is the MIMO. So first we will talk about the gap between dream and reality. It was argued about that the four MIMO benefits: array gain, diversity gain, like multiplex gain, assume ideally decorrelated antenna and full-range MIMO channel matrix. In this regard, the propagation environment and antenna gain plays a significant role. Another source of discrepancy between theoretical and MIMO gains and the practical achieved performance lies in the ability of transceiver, and whenever needed, the transmitter to estimate the channel coefficient perfectly. The second aspect we are talking about is the transmit diversity. So we will discuss there are two transmit diversity technology. The first is space frequency block codes. The second is frequency switch transmit diversity. So the first one, the SBBC, is a frequency domain version of the well-known space-time block. This family of codes is designed so that the transmit diversity streams are orthogonal and achieve the optimal SNR with a linear transceiver. And the frequency switch transmit diversity and its combination with SFBC. General SFTD system transmits symbols from one antenna on a different set of subcarriers. And the third thing we are going to talk about is the spatial multiplexing schemes. There are two ways to realize spatial multiplexing in LET. The closed-loop spatial multiplexing, which is pre-coding with codebook. And second is open-loop spatial multiplexing, which is clinic delay diversity as shown in the following figure. So, as a conclusion, the principle of multi-antenna technology and their application in LTE system was introduced, and the considerable of the difference between theoretical results and practical constraints was also present. This dissection reveals the necessity for students majoring in engineering to acquire some experience or understanding on title systems. And that's all for today. Thank you.